Hi all. It's a pleasure to have the opportunity to speak with you all this afternoon. Today I'll be sharing with you a story that I'm personally excited about, and hopefully you'll find it interesting and compelling as well. Now, the hero of our story will of course end up being the Cassandra database. And some of the other cast of characters that we'll be discussing include air conditioners, lights, meters, sensor networks, and thousands of buildings. And what we'll ultimately arrive at is how one mega retailer was able to use technology to reduce and manage their energy spend. So a little bit about myself first. I am the co-founder of a Santa Barbara-based company. And what we do is we offer products and services that are used for managing the electrical and mechanical systems that are found within a building. That includes a lot of software, that also includes some hardware. And basically what takes place with this hardware is it's installed on premise and it connects to these different systems that are oftentimes communicating using various protocols, in many instances serial-based protocols, and it provides a cohesive manner in which to interact with these different types of devices. So integrating heterogeneous device networks, that's something that we consider to be more or less a solved problem. There's a lot of companies like ourselves who have been dealing with these sorts of problems and solving them for years. And of course, a lot of the friction associated with doing things such as this have been reduced over time thanks to the adoption of various standards. So for us, where we're really aiming our focus now and where we're really trying to innovate has more to do with dealing with the deluge of information that's coming from these various sensor networks, particularly in the context of large enterprises such as retail chains. So here the stage is being set for the next 20 or 25 minutes. In the course of the discussion this afternoon, I'll be covering a few key market trends. And in the context of those market trends, we'll be discussing an energy reduction goal. We will talk about some of the challenges that we were faced in our approach to overcoming them. And we'll end by giving you an idea of what was actually ultimately delivered to the end user. So we'll obviously be discussing technology today, but since we were asked to present in the use case versus the technical track, I won't be diving particularly deep into the intricacies of our software stack or talking Cassandra data models, but instead today, I'll be painting with a much broader brush and trying to give you a better idea of sort of the nature of this industry at large, and hopefully you'll learn something interesting as a result. That being said, at the very end, I'll be providing my contact information, so if anyone would like to dive deeper, I'd be more than happy to have further discussions. So what we're going to focus on first are a few key market trends. So what are the confluence of changes that would drive a corporation to revision what's possible as far as managing their facilities is concerned? So there's three trends that I really want to highlight or focus on here. The first being the requirement for businesses, especially retail businesses, to be as lean as possible, coupled with the desire to be green. The second factor we'll be discussing is the explosion of smart devices that we're seeing today. Now, many of you are probably familiar with the term Internet of Things or IoT, and the technology that we'll be discussing certainly could be considered to be one of the verticals within this space. Now, Cisco Systems and other companies are fond of saying that today there are already far more machines and devices connected to the internet than there are people, which leads to this sort of third item, and that being, how in the world are you going to deal with all of that data? So we won't dwell on this particular topic for too long, but we're going to take a brief little detour to take a look at and spend some time discussing some of the motivators from the perspective of a real estate executive. So for brick and mortar retailers, oftentimes real estate costs end up being second only to labor when you look at what they have to deal with. And as they face more and more competition, especially from online retailers such as the Amazon of the world, real estate costs are getting even more scrutiny than they have in the past. And every retailer is looking for ways to curb costs. Now, 5 to 7 years ago, you never saw a retailer or a Fortune 500 company talking about what their energy costs were. Today, though, you'll find that corporate sustainability reports are often posted on their websites. And chief sustainability officers often report either directly to the CEO or the CFO of a company. Oftentimes, these large companies will have entire teams that are focused on various sustainability efforts. And in many instances, or most instances, the fruits of their labor are not only economically beneficial, but also are positive from a PR perspective. So those are a couple of the reasons why being green is top of mind. And now we return to this topic of the explosion of smart devices that we're seeing. So here's an image of the well-known Nest thermostat. So if you visit their website, they tell a story that's easily relatable. Here's this smart, webby network device that you can install inside your house. It's going to control your air conditioning and heating units, and it's going to help you save money. So if you're familiar with what they do, keep that in mind because it's a great frame of reference, because we're going to be talking about a lot of similar concepts, but in a commercial context. So let's explore what you might find in a commercial setting. So the story that I'll be telling this afternoon is really focused around the retail chain Walgreens. So if you went into a typical Walgreens, you would find that there are a number of major electrical mechanical subsystems. So here we have the refrigeration systems, air conditioning, metering, lighting. And from each one of these subsystems, a number of points is being highlighted there. That's what that PTS stands for. And basically, what a point is, it's sort of industry parlance for describing a piece of data that's coming from either a sensor or an actuator. Now, the point might be analog or binary in nature. It could be either an input or an output. So, for example, an analog input is something like a temperature reading or a humidity reading, while a binary output might be the relay that's closing to start a fan or turn on a set of lights. So in a typical Walgreens store, there's around 1,800 of these points. Within the refrigeration subsystem, you obviously have temperatures and pressures. Within lighting, you have the status of switches, the status of relays, information about whether or not something has failed. Within the metering infrastructure, you have information associated with the current demand, consumption, volts and amps between the different phases, power factor. You'll have your main meter, and then you'll often have sub-meters below that, so there's a lot of granularity with respects to how energy is being used downstream. And then on the rooftop, oftentimes each one of those air conditioning units are now coming shipped from the factory with a network-ready microcontroller that gives you a wealth of information. So obviously temperatures, but it will also give you information associated with the pressures in the refrigeration cycle, fan speeds, compressor status, the list just goes on and on. And this is all done in the name of energy efficiency and, of course, product preservation and occupancy comfort. So if the air conditioning fails and you leave the store and stop shopping, or if it impacts product in the pharmacy, that's a very bad thing. So what you see here broadly illustrated is how energy is typically distributed within retail. So lighting is one of the big energy spends, followed by HVAC. So if you were personally asked to take a look at one of these stores and try to optimize how energy was being used, you would actually have to look at hundreds of different devices to figure out how to go about that task. So this is why technology plays such an important role, and it's why these subsystems are as instrumented as they are. So one of the things that we find really exciting is how the nature of the economics associated with the big data deployment is really just changing before our eyes. So today you can go to AWS and you can acquire the resources that you need when you need them versus the capital outlay that may have been required in the past. Additionally, there are a wealth of open source products, mature products such as Cassandra, Hadoop, Redis, Storm. The list goes on, and these are products that are ready to be leveraged and are being used in production settings already to manage big data. So why are we even talking about big data in this session? So let's talk for a second about how you would go about interacting with the information that's derived from these points. So typically all of this information is accessible via a web browser. It resides obviously within their corporate network. So you would use your web browser to authenticate, log in, and you could take a look at a meter, for example, and see and read the present value associated with all of the sensor readings of a meter or whatever device you're curious about. Now, oftentimes on premise, these devices also have space with them for a time series log that's embedded in the device. And typically, this is a circular buffer of some sort with very limited capacity. So for example, if you wanted to know what the discharge air temperature was for a particular unit over the last 24 hours, that's pretty easy to do. That's an inexpensive operation. The information has been captured and it's there on premise. Now, if you wanted to do something like look at all of the air conditioning units across your entire portfolio and look at your discharge air temperature differentials to see how well your equipment was operating in order to figure out what equipment might need to be replaced and subject to capital outlays, that's a very different problem to solve. So for something like this to take place, the information has to be aggregated and analyzed somewhere. So what you see there is just a real simple calculation to give you an idea of the order of magnitude associated with one retail chain. So around 1,800 points per store, typically sampled at 15-minute intervals. Sometimes it's faster, but that's a safe bet. So you end up with around 58 million records per hour. Now, a lot of times you'll want to see seasonal variations. There are also metrics that you'll want to look at year over year. Or if you're looking at equipment degradation over time, you're going to want to keep this data for a long time so you can perform this analysis. So it quickly adds up. Now, I'll concede that you may not need all 1,800 of these points. And of course, there are techniques that will allow you to minimize the number of samples that you actually have to keep. But traditionally, very little of this information ends up being stored. And it's not because these sensors are without value. They cost money. They were installed in the first place because they provide some particular insight. And I think that's something that even if you're not an energy manager or understand mechanical systems, that's something that you can intuitively appreciate, that the more data, the more clean, easily accessible data you have access to, the better the decisions are that you can make. It can help you focus your resources, whether that be budget or time, and make data-driven decisions. So investing in technology such as this to manage their facilities is something that retailers like Walgreens have been doing for a long time. They literally have thousands of smart buildings that are deployed. And typically when a new solution comes online, they go through a pilot phase where they carefully evaluate the energy impact associated with the technology that's been deployed, make sure it meets our ROI model before going into a scale mode. So that all sounds great. Now let's talk about what some of the challenges are. So one of the biggest challenges associated with deployments such as this is the manner in which these systems drift over time. So when the controls contractor leaves the building, things are usually pretty well dialed in. But probably most of you have experienced strange behavior when you're entering a building, perhaps parking lot lights being on during the middle of the day, or going into a conference room that's freezing cold and finding that it's actually more comfortable outside than inside in the quote-unquote conditioned space. So there are a number of reasons why buildings which were at one point in time operating in a very efficient manner slip. For instance, sensors might fail or require calibration. Operating set points might be overridden at one point in time and are never placed back. Mechanical systems can outright fail, or there can be performance degradations. So these are all factors that ultimately contribute towards energy waste again. Another challenge that you have to deal with is your typical information silo challenge. So I think there's 3 points on this slide that I really want to highlight. The first one being that for these large enterprises, they often end up having multiple vendors' technologies installed. So if you need to compose an enterprise view of these systems, it ends up involving integrating these heterogeneous application stacks to have a cohesive view. Secondly, even within the same vendor's solution, you might end up finding silos, and these silos are really related to scaling. So for example, they may install an application server, and then 200, 250, maybe 500 buildings are connected to just that one application server, and it ends up being more or less an island unto itself. And the final and perhaps most significant challenge is that very little of this time series data that's coming from these valuable sensors is collected or analyzed. And the reason isn't because there's not value here. The reason is that it's been deemed to be technically prohibitive to do so. So the operations teams, they're often given the guidance that they need to be very selective about which information they choose to harvest if they want to have a system that still performs well. So now we'll spend a little bit of time talking about what we built. So given these limitations, we set out to build an application stack that could hopefully overcome them. We felt that the most significant challenge associated with this was dealing with the large volumes of time series data and being able to efficiently store it, retrieve it, and process it. So what you see here is a very high-level architectural, high-level view of our application stack. At some of the lower levels, conceptual lower levels, we're doing things like integrating and interacting with these devices, most often using various web services. We also had to provide facilities for modeling devices, so tagging them with additional metadata so that across platforms, there was a consistent manner in which to understand what the nature of the data was. So for example, SI units, that's a simple example. We also created a catalog for machine classifications, all with the goal in mind in providing an environment that would be ready to utilize future analytics. The environment also needed the ability to compute various rollups, of course, and we also wanted the ability to pre-compute various KPIs and analytics. So the cornerstone of the application we intended to build was really the database. We felt that if anything was going to make or break us, this is what it was going to be. So here are a few of the considerations that we had in mind when we were looking at options. So most critically was that it was something that was designed to work well with time series data. And I'm sure you've all been hearing a lot about time series data over the course of the past 2 days, but a couple of facts that I'll just briefly mention is the fact that, at least in this particular case, this is immutable, append-only data. And when you want to go about retrieving it, it's important that you get the data back as quickly as possible and that it remains in sorted order. One of the things that was also especially important for us was that as the size of the data set grew, that we were able to achieve consistent performance. So part of the reason that Cassandra came on our radar in the first place had to do with this idea of elasticity and linear scaling. So we did evaluate a few other options, but it would be a bit disingenuous for me to suggest that Cassandra wasn't the leading contender going in. From previous experience and from previous exposure to other applications that were built using off-the-shelf relational databases for time series data, we didn't think that would necessarily end up being a good fit. We did do a bit of benchmarking there using MySQL and confirmed that, at least given the level of expertise that we had on staff, we weren't going to be able to architect a performant, scalable, easy-to-operate system with that at its core. But we knew that based on the manner in which Cassandra stored data and some of the use cases that it's been consistently cited as really performing well in, that it was a good potential fit. So we spent a bit of time building out a 6-node cluster using pretty low-grade hardware just to run some tests where we generated simulated data that looked like it would be coming from these building systems. So 3 years worth of data coming from 1,000 buildings is what we ended up benchmarking. So we did this after sending a couple people to one DataStax training class. We really didn't spend a lot of effort tuning it, so don't pay too much attention to the performance numbers because I'm sure that could have ended up better. But the conclusion basically was that we were able to see this consistent performance as the data set grew, and it was measured in milliseconds, so we were pretty happy. Okay. So around 6 months ago, we started the deployment of our application stack at Walgreens. So we have a cluster of 8 machines that are running there on their data center. And these just happen to be 8 machines that they already had installed but were underutilized. So from their perspective, they were able to get this for free. We connected to 2 of the 4 major vendors that they were using. And we initially integrated 800 of their stores for sort of the first stage. One of the things that we did is we created a consistent URL scheme that could be used for representing any one of these points within the enterprise, and that URL ended up serving as a row key to access the historical data in Cassandra. We collected and harvested as much of the existing historical data as we could, and then we took over harvesting this new data. We also integrated with some utility data and also pulled in weather data from NOAA. So we worked with their team to collaborate on a number of energy-centric KPIs and went about implementing those. So for example, one of the KPIs that we worked with them on was to, given the weather data and also the historical energy consumption, to create regressions that correlated weather to energy use for the purpose of establishing baselines going forward. So they were pretty pleased with the results, particularly from the perspective of performance. So we moved on from there and recently finished adding another 1,200 stores to the cluster. And now we're starting to look at providing sort of deeper analytics at this point. So there's a lot of different ways to visualize the data. I'll just show you a couple of quick examples to give you a feel. So in this particular screen, this is just one of the dashboards that they're using. And here they're able to select a particular KPI such as energy consumption over a period of time. And then they have the results overlaid on a map and aggregated by state or region or market. So each one of these bubbles is being used to communicate 2 things. The color of the bubble indicates the relative performance when compared to other states or regions. And the size of the bubble is used to indicate the number of sites in that particular state. So this is the screen that they use for continuous evaluation of their portfolio from a geographic perspective. And I've included one other screenshot real briefly. So this is a Scatterplot. And here in this scenario, basically what they do is they select 2 different metrics in a period of time. For instance, they may choose to look at their energy consumption, compare it to that baseline, that calculated number, look over a period of 1 year. And each one of those dots ends up representing a site. So this is a great way for them to identify outliers. So once they identify an outlier, they're able to drill down from there and get more information around what's changed operationally to make it wasteful. So a few of the takeaways for us. First and foremost, we felt that Cassandra absolutely rocked for the distributed time series data store. We were very happy with that. We were also happy with the decision to pre-compute as much as possible. And some of the things that we're looking at and came to the show, in fact, to learn more about include vNodes. We're also interested in some of the security enhancements, given that it's an enterprise deployment, and also CQL3 from the perspective of revisiting how we did some of our data modeling. So at the end of the day, though, it ended up being that the most significant challenge for us and where we spent the majority of our effort ended up having to do with the time spent collecting the data, validating the data, and dealing with subtle differences between these different application stacks, which probably isn't a great surprise. But again, I think that it's a testament to how well that Cassandra ended up performing in this context, given that once it was installed and set up, very little time was needed there. So I'm not sure how I'm doing on time, but I've also included my contact information here as well. So email, Twitter, or you can find me outside if you would like to chat more.